Hi everyone, welcome to another episode with PyData Sri Lanka. So in this video, I'll be taking you all through some of the basic pre-processing steps when it comes to natural language processing. Before diving deep, I would like to give you all an idea about what natural language processing is. So first of all, we need to know what natural language is. So natural language is the language, any kind of language that we use to communicate with one to another. So at the moment, I am communicating to you all using English, and this is natural language. However, if we use this natural language, the language I am using at the moment, as an input for a computer, it doesn't have the ability to understand that. That's why we need to process that language into a format that the computers can understand. And that is the place where natural language processing comes to the spotlight. So, however, the language also has a noise, and it is important to get rid of this noise before we use them as an input for any kind of an analysis. And that's why today I will be taking you through some of the pre-processing steps when it comes to natural language processing.
Perfect. So first we need to have a data set, and my data set is stored in a CSV format. So using the Python library pandas, we are going to read our CSV file to a data frame, tweets, TF. And if you observe the data frame, you can see that there are several columns. However, we are particularly interested in this text column since we are going to apply some pre-processing steps for the text column. That means before moving to text pre-processing steps, we need to get rid of these unnecessary columns. So this line is defined to remove all the unnecessary columns and leave only the text column. And also, if there are any duplicate values, I want to keep the first occurrence and get rid of the remaining. And also, I would like to drop any null records if exist. And after removing duplicates and null values, and if I observe the data frame, you can see under the text column, we have 14,427 entries. So this is how the data frame looks like. Well, now we are ready to apply the text pre-processing steps. So these steps doesn't have a particular order, but this is like the standard format. But I should mention, when applying a step, it should be clear that the current step is not affecting the next step. With that in mind, my first step will be conversion to lower cases. Why I am converting the text to lowercase? That is to maintain a standardized format. For an example, if we take the two words cat and cat, as humans we are ready to say that both the words are referring to the same animal, cat. But without artificial intelligence, computers can't detect that these two words are referring to the same animal. So it is important to put all the words into a common format, and that is why we do lowercasing. So if I show you a tweet before applying the lowercasing step, you can see here and there are uppercase words. So to apply lowercasing, it's a very straightforward function. We are just calling this str.lower function, which is an inbuilt function in Python. And if I observe the about tweet once again, now all the words are in lowercase format and no more uppercase letters can be found. Next up is removal of URLs. If you observe this tweet, you can see that the user has mentioned a website. For most of the analysis, website addresses won't add any value, and we think it has a noise. So it is important to get rid of such noise, and that is why we need to remove URLs. So in order to remove URLs, we are using the Python library regular expressions, regex ORE, which is an inbuilt Python library. It helps us to define a pattern that can detect such kind of URLs. So I have defined the regular expression pattern here, and by applying this remove URL function to our clean text, and if I observe the same text once again, you can see that the URL is no more there. So regular expressions, when it comes to natural language processing, plays an important role. We have already done a video about regex. If you have not yet watched the video, this is a reminder, go check out this video. I will tag it here as well. Saying so, we are moving to our third step, which is removal of emails. It is also a similar step like removal of URLs. Once again, we will be using regular expressions to define a pattern. So in this tweet, you can see that the user has mentioned an email. Using this regular expression pattern, we are detecting emails and then removing. And if I observe the above text once again, now the email has been removed. Moving on, we have removal of punctuation. Earlier I mentioned that there is no particular order of applying these steps. However, if we remove the punctuations before removing URLs or emails, then the removal of emails or URLs won't be possible. Why I'm saying so, if I look into this regular expression that is to detect email, it includes this @ symbol, and the regular expressions to detect URLs include the / symbols. Both these symbols falls under punctuation. So if I remove the punctuations earlier, then detecting URLs or website addresses won't be this easy. That is why I said, though there is no particular order, we have to apply the steps in an order where the following steps are not affected from the current step. So in order to remove the punctuations, we will be using the inbuilt Python library stream because it has this function punctuation which includes all the punctuations. So if we observe this tweet, we can see that there are a lot of punctuations and we need to remove all of them. So simply what I'm going to do, we are to call string.punctuation within this function remove punctuations. And if I apply the function and observe the text once again, you can see that all the punctuations are gone. However, there can be situations where we are interested in retaining certain punctuations. For an example, in tweet data, symbols like hashtags and @ will play an important role. So in such situations, what we need to do is we have to define a custom set of punctuations that we want to remove. And after defining the custom set of punctuations, then instead of applying string.punctuation, we have to replace that with the custom set. So only the punctuations we want will be removed from our text. However, for the demonstration, I'm going to go ahead with string.punctuation, which will remove all the punctuations in my text data. Next up is removal of stop words. So stop words, it's not something that's there only in English, it's there in every language. They are like the commonly used list of words in a particular language. To detect and remove stop words, we have a beautiful library as Natural Language Toolkit, or rather NLTK. It is one of the most powerful libraries when it comes to natural language processing. So NLTK already has a stop word list for English. So what I'm going to do is I'm going to download that NLTK stop word list here, and I will print the list for you so you can see what are the English stop words. So here they are, all is, having. Likewise, there are a lot of stop words for English. And let me show you a tweet with stop words. Alright, now I am going to define a function to remove the stop words. So the function is, if the word in my sentence is not in the stop words list, I am going to retain the word. Else, I am not going to return the word. And if I apply this function to my clean text and observe the same tweet once again, you can see that the stop words are all good. Next, we have removal of numbers and other special characters. So earlier, if you can remember, we already removed the punctuations. Actually, if we are applying this function of removal of other characters, then the removal of punctuations is not necessary because punctuations are considered as special characters. However, we are interested in removing numbers as well, so let me show you this step. If we observe this tweet, you can see that there is this number 1024. To remove numbers and special characters, we are once again defining a regular expression. So in this regular expression, we are saying just retain the alphabetical characters because I want to remove the numbers and all the other special characters. That means we are going to just keep the alphabetical characters. Say that you are interested in keeping numbers and remove all the special characters, then we just have to adjust these regular expressions to include the numbers as well. Alright. If we apply this function and call the above tweet once again, you can see that the number that was there at the end is no more there. Next up, we have removal of frequent words, removal of rare words, tokenization, then stemming and lemmatization. Also, I have included 2 or 3 bonus steps for you all. However, in this video, I'm not going to discuss about them since we have part 2 of this video. Till then, have a pleasant week.